So start anyway. Yeah, it started. So anyone just confirm me whether you could my screen, right? So I'm just entirely moved into my PPT. That's why I'm just asking about this one, right? Anyone just confirm me? You could see my screen, right? Yes, anyone?
Yes, sir.
Yes,
Yeah.
sir. Yes, sir.
So these are the 6 steps. We are just going to move a little fast. Actually, we are just lagging, right? So about half a day, right? So we're just going to move into the little fast. So these are the 6 steps, right? So about metering planning. So establish program called we have discussed and identify we all discussed and data collection and development criteria and implementation and performance validation. These are the 6 major steps. So already we have started, and I'm still moving to little fast. Identify theoretical examples, units of measure, utility meters, demand meters we crossed, and classifications, right? So 10. These also yesterday we have moved, right, and installation, right. So meter எப்படி choose பண்ணாங்கற harder spec and feature எப்படி adapt ஆகணும் அது this is things we have discussed in metering installation thing. And once we just what could I say installed meter, definitely, right, we need to have accurate data. For that purpose, definitely your meter should be getting calibrated about frequently, right? Then only the meter is going to be read actual data. That's what accuracy, right? And we have just started about a special metering consideration about data centers. For the purpose, we are having a number of companies for MNC companies, and we'll have a number of meters. Definitely, the data states which is rated by the meter is very very large in the range, right? Definitely, we need to upgrade our storage devices like in automation area, data centers. We need to install and on-site power generation metering system for a combined CHP system. We need to again we need to install meters for monitoring in CHP energy also. And now we are just right away moving into metering economics. So right, so the continuation of last classes. So meter na market la vaangana definitely it would a cost, right? We need to spend a cost. So on the cost, meter ke eppadi nama spend panna porom. We'll have a number of varieties of the meters, right? For example, in mobile phones we're having a number of varieties like only 2G, 3G, and gaming mobiles, right? So, but the same 2G mobile, it only able to communicate with our other devices like only voice calling and text message. For example, my 5G mobile capability of touch screen, camera, Wi-Fi, Bluetooth, and GPRS and GPS, right? We'll have a number of facilities. That is called external functionalities, right? It's called features. We simply call it as features. Based upon features, definitely the meter cost would be very high. For example, we have discussed about the 3 type meters, right? So traditional and advanced smart meters. So definitely smart meters cost to be very high compared to my traditional meters. The same way, based upon my functionalities and features, definitely the meter cost will be high. So based upon my company code, I need to choose a particular meter. And then one more thing, right? So existing infrastructure in our industry. So already definitely there is a already installed meters will be there. So we need to, while taking a survey itself, right? So I need to check how many meters already installed my industry, and I'm just going to upgrade பண்ணணுமா இல்ல I'm just going to replace those existing meters அப்படிங்கிற infrastructure நம்ம check பண்ணணும். And then on-site specification design thing, right? So once you just installed the meters, in the sense, definitely we need to give you a overall enclosed system. So dust படாம இருக்கணும், temperatures வந்துட்டு அந்த ஏரியால அதிகமா இருந்துச்சுன்னா we need to give you an enclosed system, right? That's why rain proof, right, waterproof, and that's why we need to provide site specification designs. So that definitely அதுவும் cost தான், right? Local maintenance cost, right? So industrial maintenance cost, right? அது எல்லாமே it will be under எல்லாமே under metering system தான் வரும். Metering economicsல தான் it will be coming into place. That's why these are the some cost it will be applicable for metering thing. And the metering cost. So the metering cost will have 3 types: capital cost, labor cost, recurring cost. So what actually capital, what actually labor, and recurring? We'll see. Capital cost in the sense, while purchasing itself, we are just going to install, right? Invest money, right? That's what that will purchase time we are just going to invest money in the sense. That was my capital cost, right? And the capital cost எப்படிலாம் divide ஆகும்னு பார்த்தீங்கன்னா, for my main metering, it will be main cost. Right, definitely my energy meter, definitely it will have a CT, right? So based upon my CT value and PT value only, it's going to calculate energy. Definitely nowadays inbuilt of features la CT PT inbuilt vandrum, right? But in some cases we are just going to have a external PT and CT. definitely, but that is called my auxiliary devices, right? So definitely that would also it will be a cost, right? But actually energy meter inbuilt away இருக்கும், right? Then only you could able to calculate this energy. But in my measuring device, actual current எவ்வளவுன்னு பார்க்கணும்னா for protection purpose, right? You people already currently I'm studying protection switchgear systems, right? You people will aware about CT and PT, right? So for circuit breaking and automation purposes, right? So அப்ப நான் CTPT கண்டிப்பா யூஸ் பண்ண போறேன். So அப்ப definitely we need a purchase external CTPT. Definitely that would be a cost, right? So these are some capital cost. So once to you just have these things, right? So for example, in our power supply consumption area, in who they're just giving a power supply, that's called the energy supplier, like a TNEB or Tangent Go, right? So what actually they are just come just having, they're having a handheld meter, right? They're having handheld meter. In olden days, they're just coming to or in decision, they're just going to note it down in a meter panel, meter reading in the form of a manual paper and pen. But nowadays, they're just bringing some handheld machine, right? So actually, everything is now digital thing, right? The digital device. It's everything. It will be a microcontroller based one. So we could have input port, output port. It could easily tap it, and it could able to communicate with our onboard devices, and it could able to have a upload and download data, right? You could able to do that. So nowadays they're just coming with a handheld machine. For now, the same way in our industry, inside industry, actually private நாம என்ன பண்றோம், we are just installing meters in our industry for our own existing energy reduce பண்றதுக்காக I'm fixing my own goal. அதுக்காக நான் மீட்டரிங் சூஸ் பண்றேன். அப்ப நான் சிடிபிடி வாங்குறேன். டெஃபினட்டா நான் வந்துட்டு இதுல மீட்டரோட டேட்டா எடுக்கணும்னா ஐ நீட் டு பர்ச்சேஸ் மை கம்யூனிகேஷன் டிவைசஸ் லைக் ஹேண்ட் ஹெல்ட் மீட்டர் இருக்கலாம், இல்லை வைஃபை டிவைஸா இருக்கலாம், or fully equipped with my controllers இருக்கலாம், like SCADA, right? That's why we need to purchase communication modules also, right? If it is an energy supplier, we don't bother about those things. We are just only paying about energy meter fees only. For our own industry, நாம பண்ணணும்னா definitely நாம own handheld machine வாங்கணும், right? That definitely that will be a cost, right? So அப்ப என்ன வாங்கணும், handheld communicator வாங்கலாம், telephone modem வாங்கணும், transceiver wireless வாங்கணும், ethernet communication modem, routers, and entire data acquisition SCADA, and then these are the wiring systems, right? So that would be that way. I already told that metering is much it would be very high cost. But install பண்ணிட்டீங்கன்னா you could have that awareness of our energy. Energy awareness kadachuru, then we could easily take out take action against on my process, right? So once install பண்றது difficult, and install பண்ணிட்டீங்கன்னா we will have more awareness of our energy consumption. Definitely could able to have action against my process, right? So these are my capital cost. So meter வாங்குறோம், external CTPT வாங்குறோம், and communication modules. These are the some capital cost. It will be considered while purchasing. And then second thing, labor cost. So நான் purchase பண்ணிட்டா மட்டும் போதாது. I'm just going to bring into my company from a stockholder. வந்துட்டு I'm just going to bring it marketல இருந்து நான் எடுத்துட்டு வரணும். Transportation cost ஆகும். Plus everything is now we need to look into practical manner, right? So once we just purchased it, we need to bring it into my factory, and in the industry I'm just going to install it. Install பண்ணணும்னா சும்மா install பண்ண முடியாது. As a electricians needed around to how many meters, based upon meters, how many meters, definitely electricians, right? So they will be needed. So it's a crew of members, right? So they're just going to uh, pick a layout, and they're just going to take a trench, right? So they're just going to make a cable layout, and just going to have a fitting, cutting, welding, right? So these are the things, everything is needed, right? So definitely the metering purpose will be over. So for that purpose, everything is needed. So அவங்களுக்கு மணி கொடுக்கணும், that's called crew, travel time. So I already told that. So meter purchase பண்ணிட்டு industry கிடைச்ச travel time, preparation time, planning time, hardware installation. Hardware installation என்னது, wiring போடணும், cable layout கொடுக்கணும், cutting எடுக்கணும், and we need to have installation, we need to have a cable layout, and we need to close it again. So it will be so entire thing is now in the color for working installation, right? So connection, communication model. It will, and once we just finished it, we need to take a testing, trial and model, and we need to finally we need to have inspection. So these are the things. It will be countered by your labor cost, right? So practically thinking, it's everything is now work, right? So these are some labor cost. Once we just installed everything and we just finished it up for testing operations, right? So now recurring cost. Recurring cost in the sense, normally working maintenance or monthly once a meter calibrate, maybe 6 months on a meter calibrate பண்ண போறேன், cleaning பண்ண போறேன். These are the things it will be called my recurring cost. It will be supporting the ongoing operation of your metering system. So அதுக்கு எவ்வளவு காசு செலவாகுதோ that cost it will be called a recurring cost. That's what support your ongoing operation of your metering system. அது மந்த்லியா இருக்கலாம் or maybe based upon data frequency collection வச்சு இருக்கலாம், right? So definitely my operation perfect இருக்கணும், meter data perfect இருக்கணும்னா definitely the meters should require a periodic calibration, right? Then only we will have accurate data measuring, right? So if you're not having calibration, definitely your meter will be giving us some wrong answers, right? Definitely you need a calibration. The calibration we need to pay the money, right? So then only you could have a calibration, right? So these are some metering purchasing operation, right? This one up to metering, this one is now closed, right? We'll move into instrument devices. Well, now I'm just going to switching to my PPT once again. Yeah. Now, anyone just confirm me whether it puts my screen? Yeah, it's getting sad. Yes, anyone? Okay. And then final this overall conclusion about my metering saving potential. Metering install பண்ணிட்டா எந்த அளவுக்கு என்னால சேவ் பண்ண முடியும், ரைட்? காஸ்ட் வைஸ், ரைட்? ஸோ என்னுடைய கம்பெனில எந்த அளவுக்கு சேவ் பண்ண முடியும், தட் இஸ் கால்ட் மை மீட்டரிங் சேவிங் பொட்டன்ஷியல், ரைட்? So by I keep on, I'm just telling like that once we just installed meter alone, we couldn't able to reduce the electricity consumption, right? We couldn't able to reduce the electricity cost, right? So electricity bill நம்ம reduce பண்ண முடியாது. So indirectly we're speaking, you could have an energy awareness, right? How much energy you have utilized in this past 30 days or past 1 year, right? So we could have that awareness. So now நேத்தே சொன்னாலே we'll have a quick recall. So last month 30 days என்ன நடந்துச்சு அப்படிங்கிற ஒரு quick recap நீங்க பண்ணிக்க முடியும். Once you just got awareness, definitely you could able to run your business in the right manner, right? So next month na இந்த மாதிரி நான் run பண்ண போறேன், we could have that schedule. By making this schedule alone, you could able to restrict your wastages, right? So that's why the same thing, right? That's why we could able to saving your electricity bill, right? So for example, installation of meters, right? For example, simply I'm not what could I say? Simply I'm just installing my meter in the industry in the sense, right? So definitely 0 to 2%, right? It will have initial impact, right, in the form of money, right? But it will not be saving, right? So definitely it will not saving, but simply install பண்ண மட்டும் we couldn't able to do that, right? Now bill allocation verify பண்ண போறேன், install meter பண்ணிட்டு bill allocation wait பண்றேன். So bill allocation கூட நான் verify பண்றேன் with my metering data. அப்படி பண்ணா 2 to 5% of you will have a quick awareness about my energy consumption. So by doing this one, right, by doing this could I say awareness, definitely you could able to tune up or your load management. I already told that. So last month இவ்வளோ reading வந்திருக்கு, so இந்த month இவ்வளோ reading வந்துருச்சு, right? After my installing my meters, now we'll have quick awareness, right? கண்டிப்பா நமக்கு இவ்வளோ எனர்ஜி எப்படி அதிகமாக யூஸ் பண்ணிருக்கோம்னு தெரிஞ்சிடும். Then you could schedule your process, right? That's called a load management. You could have a load management. By doing this one, definitely you could able to reschedule your electricity thing, right? That's why I told that. So எப்படி நீங்க reschedule பண்ணணும் அந்த மாதிரி பண்ணிட்டீங்கன்னா definitely you could have a better what could I say better electricity operations, right? Then definitely it will be useful for you people, right? The industry speaking. And then ongoing commissioning, right? So எல்லா டிபார்ட்மெண்ட்டுக்கும் ஈக்குவல் டேபிள் டு ஃபார் ஒரு இண்டஸ்ட்ரியில் பார்த்தீங்கன்னா நிறைய டிபார்ட்மெண்ட்ஸ் இருக்கும், ரைட்? டிபார்ட்மெண்ட் பில்டிங், ரைட்? டிஃப்ரெண்ட் பில்டிங் அண்ட் டிபார்ட்மெண்ட் டிஃப்ரெண்ட் திங், ரைட்? ஸோ நான் ஈக்குவல் டேபிள் டு இன்க்ரீஸ் மேபி ஒரு பிளாக்ல ஈக்குவல் டேபிள் டு இம்ப்ளிமெண்ட் பண்ணிட்டீங்கன்னா தென் கோ வித் இட் செகண்ட் பில்டிங், ரைட்? ஸோ இட் வில் பி கிவிங் யுவர் கமிஷனிங் ஆன்கோயிங் ப்ராசஸ், ரைட்? திஸ் ஆர் த திங் இட் வில் பி அண்டர் மை metering savings potential. So up to this one, metering is now over. We'll move into next one, right? Any doubt up to this metering? பார்க்கறது சிம்பிளா இருக்கும், பட் இட் வில் பி ஒர்த்தி டாபிக் as well as why metering and metering பண்ணணும்னா என்னென்ன கோல்ஸ் ஃபிக்ஸ் பண்ணணும், மீட்டரிங் ஃபிக்ஸ் பண்றதுக்கு இண்டஸ்ட்ரி என்ன ஸ்டெப்ஸ் எடுக்கணும், ரைட்? ஸோ ஒரு மீட்டர்னா இட்ஸ் நாட் இஷ்யூ, சிங்கிள் இஷ்யூ. பட் while speaking about 100 meters or 200 meters in our industry, it will be matter, right? ஸோ அதுக்கு எவ்வளோ மீட்டர்ஸ் எப்படி சூஸ் பண்ணணும், எந்த ஹார்ட்வேர் ஸ்பெக் சூஸ் பண்ணணும், டேட்டா எப்படி கலெக்ட் பண்ணணும், என்ன மாதிரி கோல் வச்சிருந்தா நம்ம கோலை நான் எப்படி ரீச் பண்றது, இம்ப்ளிமெண்டேஷன் எப்படி பண்றது, அண்ட் ஃபைனலி வேலிடேஷன் எப்படி பண்றது, ஃபைனலி மீட்டரிங் இன்ஸ்டால் பண்ணா எப்படி சேவிங் பொட்டன்ஷியல் எடுக்க முடியும், ரைட்? ஸோ வில் சி ஒன் மோர் நியூ டாபிக். I'm just going to start with that instrument transformers, right? So these are the some kind of meters also. This also some meters, right? So, but we people already studied about transformers. Transformers is going actually a static device. It will be used in a transmission power line, right? So we could able to transmit your electrical power from one place to another place, right? It's a longer distance, right? But here, the same transformer, right? So we'll call it as instrument transformer. This instrument transformer is now act as a meter, right? So metering purpose, transformer use பண்ணிக்க முடியும். But we only know the meters it would be look like this. Only we just say meters na இதான் இப்படின்னு பார்த்துருப்போம். So meters na இதுதானே சார் meters. நீங்க எப்படி சார் டிரான்ஸ்ஃபார்மரே மீட்டர்னு சொல்ல முடியும், right? So these are the only meters. Meters na numbers இருக்கிறதா மீட்டர் நம்ம மைண்ட்ல இருக்கும், right? So right, so how it will be instrument transformer, right? So how it will be the same. For example, in low voltage it will be very easy, low voltage lines, right? So 230 volt 440 voltage, it's not an issue. You could have that your small metering system will be there, so like a digital meters will be there. You could easily connect it parallelly or series in such a way that you could able to measure voltage and current and energy. But in a high tension line like 220 kV or 22 kV or 11 kV or 66 kV or 130 kV, right? In a over longer transmission line, it will be a very high voltage line, right? In switchyard and substation, right? So in substation itself there is a protection circuit will be there. So how those circuits, those control system is now how it's going to working, right? Definitely it needs measuring devices in those areas, substation in thermal station, like power transmission line. So there will be automatic switchyard is there, right? So definitely it needs to measure that particular line voltage, particular line current. Definitely based upon those measurement only, that what could I say, that switchyard is going to be getting closed or maybe getting open, right? By doing those measurement only. So on the line of current and voltage measure another, then you could easily make automation over on that particular substation line or maybe a high tension line. So for that purpose, I need to measure those line and voltage, but it should be in the form of very high voltage, very high current. So you people already, maybe anyone just confirm me. So you people just crossed this instrument transformer in a PT or CT in a protection switchgear. I think you were just current semester you were just studying PhD, right? Protection switchgear. Anyone just confirm me? படிச்சிட்டு இருக்கீங்க தானே?
Yes sir.
அதுல பிடிசிடி முடிச்சிட்டாங்களா? பிடிசிடி கிராஸ் பண்ணி உங்க சிலபஸ்ல இருக்கா? I don't think so. பிடிசிடி இருக்கிற மாதிரி தெரியல. இருந்ததா? கண்டிப்பா இருக்கணும் இல்லையா?
ஸ்டார்ட் பண்ணிருக்காங்க சார்.
ஓகே. சிடிபிடி சொல்லிட்டாரு, நான் கொஞ்சம் ஃபாஸ்டா முடிச்சிடுறேன். சிடிபிடி எங்க இருக்குன்னா என்னுடைய வாட் குட் ஐ சே, எஸ் சரவணன். ஓகே, தேங்க்யூ ஸோ மச். ரைட், கண்டிப்பா சொல்லியிருப்பாங்க. ஸோ மீட்டரிங் பர்பஸ்ல மீட்டரிங் பண்ண பிறகு மீட்டரிங் அவுட்புட் இஸ் நவ் கனெக்டட் வித் மை சிடிபிடி based upon my metering data, right? So this CTPT is going to give the data to my metering system. Based upon this CTPT value, the relay is going to be getting tripped, or maybe the relay is going to be switched on or switched off for that particular devices, right? Based upon these data, CTPT or data which then the relay is now getting okay, right? Anyway, it will be very easy to for me, and then I'm just going to move a little fast because you've already studied, that's why. So the type of instrument transformer is nothing but two types: CT and PT, current transfer, potential transfer. And anyway, I'm just going to move a little fast today. CT in the sense current transformer, right? So எப்படி ஒர்க் ஆகுதுன்னு தெரியும் இல்லையா? So there is a two winding is there. Transformer two winding, right? So one is a primary winding and one more is a secondary winding, right? So these are my primary winding and these are my secondary winding. So based upon this turns ratio, definitely you could able to measure the current rate. So in standard CT, right, it will be 5 ampere. So based upon the customer will be manufacturer, they will have varieties of output, right? 5 ampere. But for example, in a minimum 5 ampere is needed, right? So what could in my I'm just talking about in overhead line, right? So it's like 11 kV or 66 kV, right? I'm just talking about those much voltages. For in those area, right? For I'm just going to switch on my switch yard about in my thing, right? So in our 11 kV voltage in my 66 kV. So for that purpose, that relay is now minimum 6 ampere is needed, right? That's why in standard it will be 5 ampere, right? நீங்க பார்த்திருப்பீங்க நம்ம மினி ப்ராஜெக்ட்ல எல்லாம் பார்த்திருப்பீங்க. That it will be around 0.5 milliampere, 0.5 ampere எல்லாம் பார்த்திருப்பீங்க. That is what very low voltage relays, right? Low voltage circuits, low voltage CT. I'm just talking about my high tension line. That's why it's 5 ampere is now minimum secondary, right? So in the secondary side, 5 ampere is now it will be there, right? So primary it will be 1000 volt, 1000 ampere, right? So now ratio it will be, we're just going to see about the turns ratio will be later, right? For example, my switch yard and high tension line, the relay should be only capable to operate at up 5 ampere. For the purpose, my secondary CT output is now 5 ampere, right? We'll see. Here I'm going to a quick recall, right? கொஞ்சம் faster போடுறேன். My secondary of my CT should not be open. It should be its closed circuit, right? It should be. These are some very important thing, right? CT, secondary CT, right? That's called secondary terminal, secondary winding of your CT should be a closed path one, right? ஸோ இப்போ நீங்கள் ஓப்பனில் வச்சுருந்தீங்க என்ன ஆகும்னா, ரைட், ஃபார் எக்ஸாம்பிள் எங்கே 1000 ஆம்பியர் நான் ப்ரைமரியில் கொடுக்குறேன். ஸோ ஒன்லி ஒன் டர்ன். For example, my second it will be a number of turns, it will be very high. So for 5 amp, this 1000 volt, 1000 current is now responsible for creating very high voltage in my secondary side. If the winding is now getting open, definitely very huge arc is going to be getting developed on my tooth end, and totally my CT is going to be blast, right? That's why we're just going to create a closed path over here. Closed path in the current flow in the room, definitely you will have a very less amount of flux lines is going to be flowing this one, right? This one. And that's why CT should be a closed path one way secondary thing, right? Already so நீங்க closed path மாத்தினாலும் சரி இல்லை எர்த் பண்ணாலும் சரி, right? So you're just going to connect this one, right? And these are the types of CT. Wound type, that is called as wound type, and bar type, and then solid core type, right? So எப்படி ஒர்க் ஆகும் உங்களுக்கு தெரியும் இல்லையா? ஸோ இண்டக்ஷன் லா தான், ரைட்? ஆக்சுவலி பேரடைஸ் எப்படி நீங்க டிரான்ஸ்ஃபார்மர் ஒர்க் ஆகுது அதே சேம் பிரின்சிபல், ரைட்? ஸோ இன்சைட் தட் ஹாலோ, ரைட்? ஸோ திஸ் பார் இருக்கு இல்லையா, திஸ் மை கண்டக்டர், ரைட்? ஸோ திஸ் சேம் மீன் திஸ் ஹாலோ இருக்கு இல்லையா, நடுவில் தான் என்னோட கரண்ட் கேரிங் கண்டக்டர் நான் பாஸ் பண்ண போறேன், லைக் திஸ் ஒன், ரைட்? ஸோ திஸ் டாட் I'm just talking about the conductor is now moving inside this hole, right? So this is what my secondary winding, and this inside hollow, right? So I'm just going to allow the flow conductor. That's what my primary. So இதுல எவ்வளவு current flow ஆகுதோ அதுக்கு ஏற்ற மாதிரி magnetic flux lines is now getting introduced on my this around this conductor. So in the flux lines is now changing with respect to my current which is flowing inside the conductor. In the flux lines is now நியர்பை நான் காயில் வச்சிருக்கேன், திஸ் கோர், திஸ் அயன் கோர், அயனுக்கு மேல என்ன பண்ணிருக்கேன் X1 X2 வைண்டிங்ஸ் வச்சிருக்கேன். இந்த கரண்ட் ஃப்ளோ கண்டக்டர் இருக்குல்ல, இது டியூ டு திஸ் மேக்னெட்டிக் ஃப்ளக்ஸ் லைன்ஸ், ஸோ ஒன் மோர் EMF இஸ் கோயிங் டு பி getting introduced on my this solid core, right? So this is what my secondary winding. See, இது நான் closed path resistance connect பண்ணிட்டேன்னா definitely the current is now flowing, அந்த current தான் my CT யோட output. This is what my bar type, these are my wound type, right? So it's a solid core. These are some types of CT. Now it is very low voltage CTs, right? You can see low voltage CTs. இதுக்கு மேல உங்களுக்கு கவர் பண்ணிருப்பாங்க, உங்களுக்கு தெரியாது. These are the tones, right? So this much tones is now tone around the 800 tones, 1000 tones, right? These are some CTs, right? For our panel board la paathiruppinga or industries, right? Panel board la we're just having these type of CTs. And then this by now clamp type of meter. So we people already seen this type of meters in my low voltage side. So multimeter கூடயே என்ன பண்ணிருப்பாங்க, this clamp கொடுத்திருப்பாங்க. Just pressing this button, right? So definitely the clamp open ஆகும். You could have an option, right? So conductor நீங்க உள்ள hold பண்ணிட்டு clamp release பண்ணிட்டு ampere fix பண்ணினா you could able to have a multimeter reading, right? So you could able to measure the current flow which is running through this conductor, right? So this is low voltage, right? So in this one more practical example hardware picture, this is a RYB conductor line R, Y and B. You could have that CT, right? So hollow type right? So this one. And this got high voltage, right? High voltage transmission line இந்த மாதிரி அங்கங்க கொம்பு மாதிரி நீட்டிட்டு இருக்கும், right? In our transmission line. So right, so overhead transmission line. This is what my high voltage CT, right? And what is the main purpose, right? So it should be what is already told that. So if I'm just going to connect my or 100 HP motor, for example, I'm just connecting 1000 HP motor, AC motor with my power supply in it, right? So definitely each each RYB it will be need to have 350 ampere, right? So RYB, so each phase it will carry about 350 amps, right? Any one CT is now reading around 500 amps in the sense, or 450 amps in the sense. definitely any one phase of my induction motor is now getting fully overloaded, definitely I need to stop this machine, right? So for that purpose I need to turn down my this relay. So based upon my CT, this CT value, R phase CT value is now giving this much data for 50 ampere. Definitely it's now load unbalanced. Definitely the motor is going to be getting turned off with the help of this relay, right? So this type of electronic based relay, right? So on the relay yaar trip பண்ணுவானா என்னுடைய PLC or SCADA, right? They will do field control, they will do. So in such a way that we need to program itself, right? We need to program in a software, right? So in such a way that the relay is going to be turned on. So அப்போ எங்க எனக்கு மெஷர் ஆகுது என்னுடைய CT தான் இட்ஸ் நவ் primary role over here. இந்த டேட்டா வச்சுட்டு தான் I'm just going to switch on my this relay, and I'm just going to protect my motor, right, against my overload. So for that purpose, this also is now working, right? And there is one more bigger hardware picture. So anyway, so protection switchgear subject I'm just going to move into much detail, right? But people already studied actually, so that's why I'm going to move a little fast manner, right? People already studied, that's why, right? These are some animation videos that will be available in market, you could see. Anyway, I'm not going to move with that, right? So these are some designing purpose which will be used, right? And then so these are some nameplate details. I just kept it for you people, right? So these are the ratio. I already told that. So this is my current carrying conductor, which is I'm just going to insert it in my inside the hollow tube, right? So this is what my solid score. இதெல்லாம் நான் windings சுத்திருக்கேன். So அதுல இருந்து வெளியில வர turns தான் S1 S2. So இதெல்லாம் நான் measure பண்ண போறோம், right? For example, S1 S2, the ratio, for example, S1 is now around 800 turns, right? So it shows that. So in my primary current carrying conductor, this is what my 800 ampere இருந்துச்சுன்னா 800 ampere flow ஆச்சுன்னா என்னுடைய அவுட்புட்ல எவ்வளவு ஆம்பியர் காமிக்கும்? 1 ஆம்பியர் காமிக்கும், right? So my output is now 1 ampere. For example, என்னுடைய inside conductor 400 ampere flow ஆச்சுன்னா எனக்கு CT யோட அவுட்புட் என்ன ரேட் காமிச்சிட்டு இருக்கும்? 0.5 ஆம்பியர் தான் காமிக்கும், right? So actually we are just step down, actually we are just stepping down, right? But actually we are just step up the voltage. So என்னுடைய கன்ஸ்ட்ரக்ஷன் பாத்தீங்கன்னா, ஸோ என்னுடைய சிடியில் ஒரு பிரைமரி வெண்டிங் இருக்கும், செகண்டரியில் n number of வெண்டிங்ஸ் இருக்கும், ரைட்? ஸோ நவ் we are now step upping the voltage and step down the current. ஸோ இங்கே 800 current ஆம்பியர் வந்துச்சுன்னா in my secondary it will be now around 1 ampere தான் கிடைக்குது. So these are practical hardware nameplate, right? So it's now current transformer practical hardware, and it will be in a high tension voltage line, right? So எனக்கு 400 ampere வந்துச்சுன்னா primaryல secondary 0.5 ampere தான் கிடைக்கும். So here we could see only one more term, right? Turns ratio, but marketல there will be a number of turns ratio இருக்குமா CTs இருக்கு. So now it will have a S1, S2, S3 on term, but you couldn't have that S3 term. We will see one more picture. So same PT, you could have different varieties of features. Already told that, right? So we'll have one more feature. So இதே CT PT, sorry, it's the same CTA. You could able to measure 1000 ampere also, right? We'll see 50,000 ampere measure பண்ண முடியுது same CT, right? So we'll have three different types of CTs will be available in market, right? So only one secondary winding, right? So இங்க பாருங்க, this is what when my straight line P1 P2, this is what my current carrying conductor, right? This is what my primary, where I'm speaking P, that's called my current carrying conductor P1. So we are just going to allow, we are just going to measure the flow of current inside my conductor, right? P1 conductor. So the secondary terminal P2. And then இதில் நான் ஃபிக்ஸ் பண்ணுற காயில், தட்ஸ் கால்டு மை செகண்டரி வைண்டிங். திஸ் வாட் மை செகண்டரி வைண்டிங் ஆஃப் மை சிடி. ஸோ இதை தான் நான் மெஷர் பண்ணுற மெஷரிங் டெர்மினல்ஸ் திஸ் ஒன். இந்த மெஷரிங் டெர்மினலில் தான் நான் மீட்டர் கனெக்ட் பண்ண போகிறேன், இல்லைனா ரிலேவை கனெக்ட் பண்ண போகிறேன், ரைட்? ஸோ ஃபார் டிஃப்ரெண்ட் அப்ளிகேஷன்ஸ், ரைட்? ஸோ எனக்கு ஒரே ஒரு செகண்டரி வைண்டிங் இருந்துச்சுன்னா தட்ஸ் கால்டு ஒன் செகண்டரி சிடி. இஃப் யூர் ஹேவிங் டூ செகண்டரிஸ், C1, S1, S2, ஸோ ஒன் வில் பி யூஸ்டு ஃபார் மீட்டரிங் பர்பஸ். ஸோ என்னுடைய மீட்டரிங்காக நான் கனெக்ட் பண்ணிக்கலாம், மீட்டர் கனெக்ட் பண்ணிட்டு அதுக்கப்புறம் எனர்ஜி மீட்டர்ல கனெக்ட் பண்ணிக்கலாம். We have energy metering purpose, right? We'll have one more secondary winding, right? It will be used for my relay operating purpose. I'm just going to connecting relay, and relay is going to be switched on my switchyard. I will just protection circuits to connect. These are my secondary winding CTs. We'll have one more one. I told you about tap changing. By changing this, it's like auto transformer. By changing this tapping, you could able to change these ratio turns, right, in such a way that you could able to measuring or capability could able to change by changing this tapping position, right? Like how auto transformer, this type of CT is also available in market. You could able to change the turns ratio also by changing this tap position, right? So these are the some more points which I'm just going to add like with you, right? And one more important thing, CT burden. ஸோ இது உங்களுக்கு எப்படி சொல்லிட்டாங்களா உங்களுக்கு? நீவன் ஜஸ்ட் கன்ஃபார்ம் சிடி போர்டன் யாராவது உங்களுக்கு டீச் பண்ணாங்க? சிடி போர்டன் burdens, anyone? CTPT burden சொல்லியிருக்காங்களா? So anyway, I'm just going to give you. ஸோ போர்டன் இந்த சென்ஸ் நீங்க சொல்லியிருப்பீங்க இல்லையா? ஸோ ஒரே போர்டனா இருக்கு, ரொம்ப தலைவலியா இருக்கு, ரைட்? ஸோ இட் ஷோஸ் தட் ஓவர்லோடிங், ரைட்? ஸோ எனக்கு என்னோட முடியல, இவ்வளவுதான் இருக்கு, நான் இவ்வளவுதான் படிப்பேன், எனக்கு இதுக்கு மேல கொடுக்குறாங்க, தட்ஸ் கால்டு போர்டனா இருக்கு, ரைட்? So it shows that this is now meter. So this is my current conductor P1. This is what my current conductor P1, and this is what my lead wires, right? So these are my simply they would call it as pilot wire in market. In hardware, they're speaking electrical engineer people who they are working in high voltage tension line. They will call it as pilot wire, right? Instrumentation engineer, they will call it as pilot wire. We people call it as lead wire, right? So no issues at all. Right, S1 S2 நான் கனெக்ட் பண்ண போறேன். இந்த கனெக்ட் பண்றதை நான் எங்க கனெக்ட் பண்ண போறேன்? I'm just going to have two option. So for metering purpose, I'm just going to connect meterings, right? So meter நான் கனெக்ட் பண்றேன், right? மீட்டர்ல கனெக்ட் பண்ணிக்கிறேன் for measuring flow of current inside my this conductor, right? And we'll have one more thing, right? We could able to connect one more CT to CT value to my protection relays, right? So protection purpose, I'm just going to connect with my relay. So right, so now you'll see, for example, let us consider this. If it is this motor, right? Let us consider if this is a motor, right? Right. I'm just going to connect a load meter 1, meter 2, meter 3, and one more relay 4. So totally 4 object is now connected with my motor. Upon motor ki dana load the same way this CT, right? So this CT is now connected with this type of meters 1, 2, 3, and relay including 4. 4 devices is now connected with my CT. So in the knowledge device, so it's now act as a load to this CT. Right, that's what a burden of this motor. So இது ஒரு load act ஆகும். இந்த meters and relays is now connected with my CT. That's why it's called burden in the sense connecting load. How many loads is now connected with my CT? That is called burden. அது எப்படி நம்ம calculate பண்ண முடியும்? Right? We'll have CT burden types. One is a zero burden, typical burden, and high burden. Zero burden in the sense, right? So there is no what could I say? No relay and no metering device is now, and there is no meter is now connected. Simply I'm just short circuited. So right, so அப்படிங்கிறப்ப definitely short circuit voltage another zero, right? அப்ப இந்த மீட்டருக்கு zero burden, right? So there is no voltage drop. Simply having short circuit, I'm not having any meter, any ammeter and any relay. So nothing is now connected in my second end of my CT. Definitely short circuit voltage is zero. Definitely there is no voltage drop, there is no power drop. So zero burden type. And we'll have one more type, typical burden, right? So in this typical burden, right? So this one my current conductor. So I'm just having CT ratio. Primary is now 500 ampere, and my second is my 5 ampere output, right? So this is what my turns ratio, CT turns ratio for a particular this hardware CT. Primary 500 ampere, and second it will be a 5 ampere. Now in my secondary end of my CT, I'm just connecting on ammeter, right? So this ammeter resistance, right? So because of everything is now connected to my conductor, so its own, this conductor itself, it has its own resistance 5.5 ohms, right? Now we need to calculate a voltage drop across this meter, right? We need to calculate. ஸோ அப்போ எனக்கு ஆர் கிடைச்சிருச்சு 0.5 and ஆம்பியர் கிடைச்சிருச்சு வி. We need to able to calculate V. So V another actually voltage drop across means my CT I into R, which is like simple Ohm's law. So we know already I, so 5, we know R 0.5, right? 0.5. Totally now 5 into 5, 25, so 0.25. So totally 2.5 voltage, right? So this is a voltage drop across it my second CT. Right, so now we are just talking about load actually. So how many load is now connected with my CT? Upon a load calculate panona, that's called a demand factor. We just already discussed about demand, that is called voltage ampere. That's what it's called a demand. This is what my load, right? So load is now connected with my particular power supply source, right? That's what called a demand, that's called a load, right? So load எப்படி calculate பண்ணனும்னா, we need to now calculate power, right? We need to calculate power. So power formula another, so it will be what could I say, V into I. That's called my power formula, right? So we know already the voltage drop across my this thing is now 2.5 voltage drop across this my CT secondary, and the current which is now running through my this thing, right? So in my secondary it is now 5 ampere. So now totally how much power? 5 into 10, 10, 10 and 5, 2.5. So 12.5 already we have seen here, right? So Borden. So 12.5 Borden. So this one, right? So for example, in my market, right? So this is my standard ratio about my high tension CT. So high tension CT always it will be in a market. You just Google it or maybe just visit some local market. The standard it will be 5 ampere output. So this high tension CTPT. That's right. So our ratios, Patina, I'm just going to show you on hardware, right? It will be around 20 VA, right? So I'm just going to show you a more practical picture. The total typical burden of my CT about 20 VA குள்ள தான் இருக்கும். ஸோ இதுக்கு மேலே இருந்துச்சுன்னா அந்த மேனுஃபேக்சரர் அந்த ப்ராடக்ட் நீங்கள் வாங்க வேண்டாம், ரைட்? ஸோ that CT value it will be somewhat wrong, right? So predict பண்ணுவோம் accuracy it will be very low, right? So it should be under below 20 VA. If it is a turns basis 500 by 5, right? So this is a typical burden. And what, right? So this is a real one more hardware picture. So while just purchasing market in our CT, it's already told that this CT is now that communication for RS 485 for communication purpose, and we'll have AC main power supply for this CT, and the CAT communication will be there, and RS 232 communication will be there, and we'll have auxiliary things, right? So load, these are the things, right? You could able to connect a number of ammeter, watt meter, relays, right? You could able to connect from these terminals, right? And here this typical Borden will be here 5VA, right? They are already marketed in a 5A category 2. So while seeing in a data set, you could easily understand how actually this one. And in high Borden, so high Borden in the sense I'm just now connecting on a relay, right? So typical relay is now connected. In the relay order resistance will be now 5, right? So it will be 5. So metering pathina very low. It's not actually low. It's only a conductor will be connected over here. So conductor resistance மட்டும்தான் வரும். But in my relay it will be a group of coil. It will be there. My resistance will be somewhat very good. So now we could able to calculate what would you say your high board. We could able to give you high board. Say because my resistance will be very high, right? So now voltage across my this secondary CT 5 into 5 voltage into resistance. Sorry, current into resistance will be with V voltage drop in our current ohms law. So 25 voltage drops, right? 5 into 5 resistance I into I, and then power across my this load around. So 25 voltage into current, which is now flowing through this circuit 5 ampere. So it will be around how much? 5 into 25, 125. So 125. So it will be very high, right? So very high for this total demand, right? So it will be, that's why it's called a high border, right? And then the total Borden calculation, right? So around it's not 125, right? 5 into 25, right? And then CT Borden calculation. So ஒரு CT meter வாங்கிட்டு அந்த CT கூட நம்ம எவ்வளவு டிவைஸ் நம்ம கனெக்ட் பண்ண முடியும், right? We already told that it should be below 20 குள்ள தான் இருக்கும். It should be below 20 குள்ள தான் இருக்கும். அதுக்கு மேல போக கூடாது, right? So 20 குள்ள தான் இருக்கும். ரைட். ஸோ சிடி போர்டன் கால்குலேஷன் ஒரு சிடி அந்த சிடி வாங்குறோம்னா இது கூட என்னென்ன மெசரிங் டிவைஸ் எவ்வளோ டிவைஸ் தான் கனெக்ட் பண்ணணும், அதை கனெக்ட் பண்ணா என்னுடைய டிமாண்ட் வந்து இவ்வளோக்கு மேலே போகக்கூடாது, 20 விஏக்கு மேலே போகக்கூடாது. ஆல்ரெடி டோல் தட், ரைட்? ஸோ ஆக்சுவலி தேர் ஜஸ்ட் கனெக்டிங் அபவுட் திஸ் 5 டைப் ஆஃப் மீட்டர், ரைட்? ஸோ ஒன் அம்மீட்டர், ஒன் மோர் அம்மீட்டர், one more ammeter, and one more trimeter, that's called energy meter, one more relay. So we are just now calculate about individual calculate பண்ணோம். So total CT கூட இவ்வளவு டிவைஸ் கால்குலேட் சீரிஸ்ல கனெக்ட் பண்ணிருக்காங்க. Now total VA could able to calculate, right? So எல்லாத்தையும் நீங்க என்ன பண்றீங்கன்னா ஆட் பண்ணுங்க. So total VA it will be now சீரிஸ்ல கனெக்ட் ஆயிருக்கு. 2 plus 2 4, 4 plus 3 7, 7 plus 2 9, 9 plus 4 13. So total 13 VA is now connected series with my CT, right? So now total lead that's wire resistance should be a 0.1 ampere, sorry 0.1 amps, right? So 0.1 ohms, right? So now we need to calculate voltage across my this thing entire thing. So 0.1 resistance into my current flow, which is now 5. So total voltage drop is across my CT secondary is now 0.5 voltage. right? 0.5 voltage, and we need to calculate the total power is now 0.5 voltage into V, and current it will be 5, right? So 5, so 2.5, right? So again add this 2.5, it will be around 13 kVA, and it will be around 15 16 தான் வருது, right? So it will be below 20. So it will be a good one, right? So இதுக்கு மேல கிராஸ் ஆகக்கூடாது. அப்படி கிராஸ் பண்ணீங்கன்னா என்ன பண்ணும், இதுல வந்து ஒரு மெஷரிங் டிவைஸ் we need to remove it, right? So CT வந்து ஓவர் போர்டன் ஆயிடும். So definitely it's going to give you a wrong reading. So that's why we just going to remove any one of this external devices which is going to be connected to the secondary of CT, right? So now it's coming to PT. So the same thing, I'm just going to move little fast. PT, it will be very easy, the same thing, right? Same procedure. So it will be is going to measure a voltage, right? So it should be voltage. CT is now going to be connected in a series mode in my line, and for measuring voltage, we need to connect it in a parallel mode, right? That's a major difference. So points to be noting in my thing is that my primary should be a short circuited. It's called it should be earth, right? Should not be shorted, right? But should be my primary end is now going to be earth, right? It's a very important thing. So my primary end is now going to be earth panel, right? So that's a very main important thing, right? And for above, what could I say? For above measuring 130 kV, right? Above 130 kV க்கு மேல அமைச்ச பண்ணணும்னா, so I need to add capacitor series with my lines, right? So என்ன பண்ண போறோம்னா, capacitor add பண்ணோம்னா the voltage drop ஆகும். So voltage drop ஆச்சுன்னா definitely you could able to step it down and you could able to measure it, right? So capacitor add பண்ணுவாங்க in very high voltage lines, right? So above 130 kV, right? So capacitor series connect பண்ணுவாங்க with parallel. So capacitor already people know though, right? So கண்டிப்பா voltage drop ஆகும். Voltage drop ஆச்சுன்னா definitely you could able to step down a voltage and you could able to measure it. Why actually inductor is over is connected over here in the sense, if you're just going to connect any capacitor in my AC circuit, definitely there is a power factor issue, right? So definitely the current is now leading my voltage. For that purpose, I'm just going to getting a normal control. I need to add inductor. So if inductor connect current is going to be lagging, so lagging and leading. So both are cancelled each other. It will be voltage and current will be are in both in phase, and you could easily measure our voltage in a particular level, right? So we need to step it down and we need to measure it. So in very high voltage, we need to add capacitors and inductors, right? Then these are the things is now going to be reducing your voltage level, right? So the capacitor is now going to be used over there, and we could able to make it measuring, right? So over here, this and the remaining thing will be same. And this one more thing which I just got from internet. So this is circuit about this is a series connection. So voltage, right? So this is my load, and my what could I say? My this got my PT. PT is now connected parallelly with my load. Then you could easily, that's a voltmeter, right? Simply it's now voltmeter which will be connected parallel with my load. Then you could easily measure my voltage. And this is what my load, my CT is now connected series with my load. Then you could easily measure ampere. That's why small comparison just taking, and it's going to give you a screenshot, right? And the way that it's called, with that I'm going to move, finish it. Remaining 10 minutes is more noise to set up. We'll see one more small concept, paralleling CTs, right? So you could able to connect two CT in a parallel mode, right? It will be very easy. So you could able to connect CTs in parallel, and as well as you could able to connect a series of two transformers also. So when CT is now connected in parallel mode, right? What is going to happen? If two CTs are connected in parallel, so each CT is now about measuring up at 100 ampere in the sense, total it will be 200, right? So total will be 200. Right. So if three CT is now connected to parallel, so it will be average, it will be 150, right? So this is the one more important thing, right? So we'll, what are the main guidelines to connect it on series with parallel to CTs, right? CTs is now seriously connected with my load, but while measuring, CTs is now connected with my thing, right? மெஷர் பண்றப்ப சிடி சீரீஸ்ல இருக்கணும் லோட்ல, பட் நான் பேரல்ல தான் கனெக்ட் பண்ண போறேன் ஃபார் மெஷரிங். டிஃப்ரெண்ட் சிடிஸ் நான் கனெக்ட் பண்ண போறேன், ரைட்? மல்டிபிள் குரூப் ஆஃப் மல்டிபிளர்ஸ், ரைட்? And that internal burden should be calculated. So it should be for a different meter, it will have different burden rate. So அதனா வந்துட்டு பேரலா கனெக்ட் பண்றேன்னா, ஸோ எல்லா பேர்டன் ரேட்டும் ஒரே மாதிரி இருக்கிற மீட்டர் நான் சூஸ் பண்ணேன்னா இட் வில் பி வெரி ஈஸி. பட் பேர்டன் டிஃப்ரெண்டா இருக்கிற மீட்டர்ஸ் நான் சூஸ் பண்ணேன்னா the result will be somewhat improper, right? So we need to, while calculating parallel CT, definitely we need to look into burden rate. So on that right, different burden meter reading, it will be different reading. That's why it will be these things, right? Do not exceed the maximum ampere rating of any individual CTs. For example, ஒரு CT வந்து 100 ampere எடுக்க போறேன், இன்னொரு CT வந்து 200 ampere எடுக்க போறோம்னா, definitely it will give you different rating, different output rating, right? So it will be a we need to while connecting in parallel, we need to be keep in our mind that, right? So every CT should be a same rating, and then this is a very important thing, right? And if it's going to deduct actually in CTs, right? If it is a both are connected in parallel, definitely it will be very difficult to detect wiring issues, right? So in the error is going to detect because it will be very difficult because we are just connecting three CTs, right? In our previous example, we are just connecting three CTs. So three CT ஏதாவது ஒரு CT வந்துட்டு error இருந்துச்சுன்னா எனக்கு கண்டுபிடிக்கிறது it will be difficult. So I'm just only getting cumulative output, right? So 50 ampere எனக்கு 150 ampere காமிச்சிட்டு இருக்கு. ஸோ ஃபார் எக்ஸாம்பிள் ஒன்ல வந்து ஒரு சிட்டி எனக்கு ஃபைனல் அவுட்புட் எனக்கு 150 தான் காமிக்கும். ஐ couldn't have இண்டிவிஜுவல் அவுட்புட், ரைட்? ஸோ அப்படிங்கிறப்ப ஐ couldn't able to find out this errors were actually happening. அது தெரியாது, ரைட்? அண்ட் ஒன் மோர் இம்பார்ட்டன்ட் திங், ரைட்? ஸோ இந்த சிடி பேரலா கனெக்ட் பண்றப்ப என்னோட வயர்ஸோட திக்னஸ் இட் வில் பி 18 அமெரிக்கன் வயர் கார்ட்ஸ், ரைட்? ஏடபிள்யூஜி இவ்வளவுதான் மேக்ஸிமம் இருக்கணும், ஒரு ஸ்டாண்டர்ட் இருக்கு. So we need to follow these things also. It should be about 18 American wire cards thickness, right? So that CT parallel connect பண்றப்போ. And this is one more example, right? So how actually CT is now connected parallel with it, right? So actually three phase is now coming for 200 HP motor we are just using, and phase 1, phase 2, phase 3, right? So three more power supply. So total ampere pathina 1200 ampere maximum is power supply is now coming. So each phase is now consist of 400 ampere. So now three CTs is now connected in parallel, right? So R phase, Y phase, B phase, அதுல மூணா பிரிச்சிருக்க, ரைட்? ஸோ ஆர் ஃபேஸ்ல மூணு, பி ஃபேஸ்ல தனியா மூணு பிரிச்சிருக்கேன், ஒய் ஃபேஸ்ல மூணா பிரிச்சிருக்கேன். அண்ட் தென் ஃபைனலி ஐம் ஜஸ்ட் கோயிங் டு குரூப் டுகெதர், ரைட்? ஸோ கண்டக்டர் பார்த்தீங்கன்னா ஆர் ஃபேஸ்ல இருந்து வருது, அதை மூணா பிரிச்சிருக்கேன். இந்த சேம் வே ஹியர் ஆல்சோ. ஸோ ஒவ்வொரு கண்டக்டர்லையும் ஐம் ஜஸ்ட் ஃபிக்ஸிங் சிடி. ஸோ CT1, CT2, CT3. These three CTs are now connected in parallel, right? So three CTs are connected in parallel. I'm just measuring about 1200 ampere. The same way, three CTs are now connected in parallel, right? I'm just going to connecting output, right? The same thing. So this is what a CT connection, right? Up to this, I'm just going to pause it over here, right? We'll meet by forthcoming classes with one more topic. Up to this, the CT will be now getting closed. Next class, we are just going to see about multitasking, right? I'm just going to share one more tab. இப்போ we are just leading batch 1, right? So கொஞ்சம் நம்ம ஃபாஸ்டா போனதுனால batch